Hi, I am Drishti from Software Engineering from X1 batch. So, ma'am, as you asked to make a video explaining the concept related to question 4. So, this is the question 4 of 6.1p task of OOPS. So, here it was asked examine the following code and represent the classes and the relationship as a UML diagram. So let me first go through the UML diagram and explain my UML diagram to you. So this is my UML diagram. At the top we have the animal class, which is an abstract class. It contains an abstract method called greeting, which means it does not have a body and must be implemented by its child classes. So the arrows in the diagram represent inheritance relationships. The cat and dog inherit from animal, which means they reuse its structure and provide their own implementation of the greeting method. The dog and big dog, the dog class also have an additional overloaded method greeting. The big dog class further extends dog and showing multi-level inheritance. It overrides the greeting method and defines its own version of greeting. All child classes override the greeting method, which means the same methods behaves differently depending on the object. This is an example of polymorphism. The hollow triangle arrows points towards parent class, showing the that this is a relationship. For example, cat is an animal and big dog is a dog. Overall, the UML diagram clearly shows inheritance and method overriding and the class relationships in the program. So, this was my UML diagram. Let us go through the code. Object class. I think I explained the code. Class structure. In this program, we have an abstract class called animal, which contains an abstract method greeting. Since it was an abstract class, we cannot create its object clarity. Then we have three subclasses: cat, dog, and big dog. Cat and dog both inherit from animal and override the greeting method when with their own implementation. Big dog further extends the dog class, which shows multi-level inheritance. Multi-level inheritance. Each subclass provides its own version of greeting method. This is called method overriding, where the same methods behave differently depending on the classes. When we create objects directly like cat, dog, big dog, and call greeting, each object executes its own method. For example, cat prints meow, dog prints woof, and big dog prints woo. A polymorphism is demonstrated when we use a parent class reference to refer to a child class object. For example, animal, animal 1, new cat. Even though the reference type is animal, the method of an actual object, which is cat, is executed. This is called runtime polymorphism. When we try to create an object of the animal class directly, it gives an error because abstract classes cannot be instantized. As we know, the dog class has overloaded method greeting, and big dog defines a similar method using a new keyword. This shows the method overloading and method hiding, where big dog provides its own version of the method. In conclusion, this program demonstrates OOPS concepts including inheritance, polymorphism, abstraction, method, overriding, typecasting, which are essential for designing flexible and reusable software systems. So, thank you, ma'am.